Greeting, I'm Mark, and as many of you, I love coding. Today, I am going to be working with Processing 3, which is a Java language, and I'm going to show you a couple of things that I had difficulty understanding when I was first starting out with this language and many others. I had difficulty understanding polar coordinates and also nested loops. They can be tricky and quite confusing. And so using our little example here, what I have up on the screen, which is called a Metatron's cube, it's a part of the sacred geometry group. We're going to use polar coordinates, we're going to use nested loops, and we are going to create this sacred geometry. Okay, now the first thing I'm going to do here to get started is open up my processing IDE. Now what I have done in it, and some of you might, it's not recommended, I've preset up some of these things because it is not a default in processing when you start a new processing sketch. And what we got going on here is I like to see the setup, which is the setup function, which is always going to be in every processing sketch, and the draw function. Now what I've also added to this is a set location function, which what this does is it puts a little bitty, my sketch up rather, whatever size. Right now it would be little bitty, and I can show you that. You can barely see that little screen up here. It puts it up in my upper right corner each sketch. That way it's kind of out of the way when I want to run my sketches. And what we're going to do here first off is we're just going to create the size of our sketch window. For my system, I'm using a 4K system display, a 4K display, and I'm going to make this 800 by 800. If you have a 1080p display, you might want to take these numbers and divide them by 2. And right now we can run this, and now you can see my little 800 by 800 processing sketch. Let us continue. Now also what I do is once I start my sketch, what I should have showed you before I typed in anything else, is I like to do a save as. And let's just call this MC for Metatron's cube. All right, let us continue. Now, if you look at our little sacred geometry design, our Metatron's cube, you'll see that it contains several circles, and each circle is connected from a central point to every other circle. What we are going to do is we're going to create two separate functions to create this. As far as the drawing is concerned, we're going to first create a circle function, then we're going to create a line function. To do the circles, we're going to create one more function which will calculate our polar coordinates. And so let us get started. First, let's look at each circle. Each circle, as you can see here, if you're familiar with this geometry, there are 13 circles starting with the center one. 6 around that, the same size as the center circle. And then 6 around those, the same size as the other circles. And all of them have something very similar. Not only the diameter, not only the radius, but also the thickness of the lines that creates them, which we call stroke weight. You can see the lines that connect them are a smaller stroke weight. So we're going to be working with that. And the other thing that they all have in common is they have a location. And what we want to do is create a variable to store all these locations. And so what I'm going to use is what's called a p-vector. Now p-vector stores X, Y, and Z locations. But since we have 13, we are going to use an array so we can have 13 locations. And for our purposes, we're only going to be using an X, Y location. So let's call that C points. C points, and we're making it an array. And we're going to also initialize the array, which you don't have to do here. You can do it in setup, but I am going to do it here. Again, p vector. And we just want to put the brackets, but we're going to say 13 because we have 13 circles we're working with. Let me see. Did I do? Oh, wait. You can't just say p vector. You have to say new p vector. Okay, let us continue. What else does these circles have? Well, as we said already, they have a x and y location. And so, and when you're working with xy values in processing, let me show you what I've got, little visual aids for you. Processing uses Cartesian coordinates. Their origin point all are up in the upper left-hand corner, which is the 0, 0 point. If you extend out on the x-axis, it's all positive numbers. If you extend down from that point on the y-axis, it's all positive numbers. And we're going to right now define or initialize our xy points, which we'll be using later on. Now, in general, these are integers, but for certain math I'm going to be doing, I'm going to create floating points. And we're going to say x, comma, y. And as you can see, I'm putting a semicolon after each line of code. With very few exceptions, you'll find you have to do this. Right now, what I want to do is do a Control S for save. I try to do that often because it happens, as they say. All right, let's continue. So what else does these circles need? Okay, we've got location. Well, I think what we need here is a diameter and a radius. And so what we're going to do is add that into our float. I'll start with radius and then diameter. I'm just naming them as they are. Fortunately, they aren't reserved words like processing has, like text and setup and draw. You don't want to be using those. All right, as we move on, next thing, pretty much the last thing about these circles, we've got location, we've got radius, we've got diameter. The next thing would be the stroke weight. Now the stroke weight is an integer, non-decimal number, and we're just going to call it SW for now. Okay, now what I'm going to do from this point, I'm going to start working on, I'm going to first do a save, and then I'm going to start working on the circles. They're going to do the circles. And in fact, what I like to do, I'm going to create a function to do the circles, and I clearly can just add it to the sketch on this tab. But what I like to do when I have a lot of functions going on, when I have a lot going on in code, I like to make a lot of separate tabs. It makes it easier going through the code instead of trying to look on a length of code to find something. What we're going to do is create another tab. Clicking up here and then this little arrow, I'm going to create a tab and I'm going to call it Do Circles. Okay, now within here we're going to create a function. Every function starts out with some kind of return value. If there's no return, you type in void, which means that this function, which we are going to call do circles, the results of this function can be used globally. And so it can be called from anywhere in your code. And I like to open and close all my functions with the curly braces right away because sometimes they can get long and you can forget. I also do that with if statements and for statements and while statements. Pretty much every one that needs to be contained within curly braces, I try to get those typed in immediately because you can forget. And then you're searching for that freaking curly brace, and sometimes you have so many in your code that it gets quite confusing to figure it out. Okay, so what is the first thing we're gonna do? Well, the first thing we want to do here is understand how we are going to lay these circles down. This is where I figured that polar coordinates would work best. Now you can do other forms of math, try to figure out how to place these exactly where they need to be, but I found after trying it a couple different ways that this worked out the best using polar coordinates. And right now I'm going to show you what polar coordinates are all about. Let's bring up a couple of more visual aids. I think up here helps describe it pretty well. This is Photoshop. So a polar coordinate is just like the name says, it's a circular thing. It starts with, say, pretend like there's a pole coming out of the middle of this, straight out towards us, and everything radiates outwards from that center point. As you can see here on the orange lines, go out this way and this way. We call them radiuses, which is basically half the diameter of a circle. Now, for our purposes, we are going to do something called translate. Now, what translate does is it takes, let's minimize this and let's go to another visual aids. It takes our default Cartesian coordinate and takes our origin point, and whatever we translate to, it will put it anywhere on our screen grid. So what we're going to do right now is we're going to translate it, because what we want everything to do is emanate from the center of our screen and work our way outwards with this little loop that we're going to create to do this. We want to basically, with translate statement, translate dividing the width of the screen in half and the height of the screen in half, we put our origin point in the center of the screen. Okay, let's go back to our Photoshop. Now, what we got here is these two more or less vectors shooting out from an origin point, which we are going to create. What we are going to use, let me move this so you can see it a little clearer, is this trigonometric function, these two, for creating our polar coordinate. And how we're going to do that? Well, it's all about one thing, is the angle between these two vectors. We call that a theta. Now, with this number and a radius number, we can calculate an x location and we can calculate a y location. Okay, now we're going to put up a background. Things are going to get a little bit cluttered here. Again, you can see how this would work on a Cartesian coordinate level. Creating a radius times sine theta gives you a y location. Then the x location, the same radius, the same angle, cosine that angle, theta, times radius, and you get your x location. Okay, now here's where it gets really fun and a little bit more confusing. So I'm going to get rid of this for now, and I'm going to pop this up. This is our Metatron cube. Now, how does this work? If you look at our design here, you can see that from the center there is 6 lines radiating outwards from the center. Let me see if I can make that a little clearer for you. Let me see here. Does this do it? Okay, 6 lines radiating outward. Let's get this off here. 6 lines. Now with the processing, the default when you're working with polar coordinates, the default is from your origin point going off to the right is 360 or 0 degrees. As you come around clockwise, you get to 90 degrees, clockwise 180, clockwise 270. I have this 300 here because we are going to be using it. Okay, now over here, what's going on is we have to calculate our lines, our 6 positions. 6 positions. To do that, we have a math going on. And what we want to do is take those 6 positions and divide it by the 360 degree circle. The number you have left is 60. And so in between each one of these angles is 60 degrees. And so between each one of these lines is 60 degrees. And we are going to use that. Now, one other thing about how we're going to do this is that radius number. We already know what our angle is going to be. We know it's going to be 60 degrees. And to get this 60 degrees here, say we want to do this line right here, right? Well, we want to say plus 60 degrees. And then this line, we want to add another 60 degrees. So that's 120. And then this line, we add another 60 degrees, 180. And to get this line, we're going to have another 60 degrees until we complete our 360 degree circle. Okay, so each one of these has a circle. Each one has a center point, a location. Now, each location is going to be our radius going outward in our circle. And so our first location is the center of the screen. Pretty easy. Second location is this point over here in the center of this circle. What we need to know is the distance between here and here. Well, in this sacred geometry, we're using these circles all equal, same size, and that's the diameter of the circle going from this point to get this point plus the stroke weight. And then you get to this point. And then we're going to add it again, the same diameter plus the stroke weight to get out here. And each time we do that, our radius is going to change. And hopefully you kind of get what I'm talking about here. All right, so the first thing we want to do and do circles is we want to tell it to translate. Translate to the center of the screen. And again, that is width divided by 2, comma, HEIGHT divided by 2, width and height. And so now our origin point is changed to the center of the screen. And next, we're going to start. Now we see 1, 2, 3 rows. We're going to start from the center, outward, and outward, as I said. So we're going to start our first loop. Our first loop, 4. Now we have to initialize or declare our variable. And we're going to initialize it as well. Now we're going to use the variable j equals 0. Now that we've declared that, j will always only work and can only be, this particular j can only be controlled within this for loop. And if you try to access it outside the for loop, you'll get nothing. You'll get an error. So we want that, and we want to say as long as j, and how many rows each Each time we go through, it's 3, as long as j is less than 3. And so it starts out with 0, then it goes to 1, then it goes to 2. That's 3 of them. Hits 3, it's out of the loop. Okay, and then we're going to increment j by 1. Plus, plus. Now we can easily say j equals j plus 1. We could say j plus equals 1 or 2 or whatever for incrementing. Since we're only incrementing 1, this works fine. And again, we're going to open curly braces, close curly braces, and that is the beginning. Okay, we start that loop. That creates the outer circles. That creates your outer rows of circles. Center, then it goes to the next row. Center, next row, outer row. Now how do we get it to do each one? We're going to create another for loop. And we're going to say for, and this time we're going to use int I, and we're going to say equals 0. And then we're going to say, because there are 6 circles, we're going to say as long as I is less than 6. And then we're going to increment I, same way we incremented j. And we're going to open curly braces and close curly braces. And our loop is still there. We have no errors at this point in time. And hopefully that continues. But I'm sure there's still time. Now, the next thing I'm going to do, there is something that needs to be done before this, but we're not going to do it yet because it might get too confusing. What we're next going to do is actually draw our ellipse. E-L-L-I-P-S-E, ellipse. And we want to say X, Y coordinate. All ellipses, first thing you need to do, and most shapes and processing, is set their location. X and Y location. Now, we want to set the size. In this case, the default value is diameter. And that will be the width. And the height, again, diameter. Now I can copy the previous, diameter. Okay, that creates our ellipse. Now, if you can follow our logic here, first time through it's 0. Second time, our next thing it does is come into this part of the loop here and starts at 6. It's going to draw 6 circles. Then it's going to hit 6, and it's come out of there and draw 6 more circles. And then come out of there for the third one and draw 6 more circles. Well, in the center there's only 1 circle. So how are we going to deal with that? What we're going to do is, since we've already done this in the beginning, we created a radius. Now, if we don't set that equal to anything, it usually defaults to 0. But what we're going to do, just in case, is we're going to say radius equals 0. And go back over to our do circles, and then we're going to test our radius. So we're going to say if radius equals 0, what we want you to do, since you've already drawn a circle, if it equals 0, which means that is our origin point right here. There's no radius. It's not going out anywhere because it's 0. Center circle. If it's 0, what do you think we're going to do? Here's something you might not have thought of. What I'm going to do, and I'm going to basically break. I'm going to break. Now when you write break, when you create break, what happens is if you're in a for loop, it kicks you right out of that particular loop. So it's coming through our loop expecting to do it 6 times. It draws its first circle, sees that it's on that radius is equal to 0, so it's drawing only the center circle, then it breaks out of that loop, just as if it had 6, so it's gone. But for brevity, since it's so short, we're going to just put it on one line. Some people might find that confusing. Now after that, what we want to do is increase our theta to the next position. So we started out our first theta. Well, in this case, it's interesting because, let me see if I can do this way. Yes, okay. Our first theta is radiating out towards this way. So its first circle, even though it's in the center here, it's based on the default, which is a 0 and 360 over here. And now we're going to increase it, the theta. We're going to increase it and we're going to increase that by 60 degrees. We're going to do it like this. We're going to add plus equals. So basically I'm using the same variable to just add to that, not renaming it. And we're going to say radians because processing 3 defaults to radians, like 3.14 yada 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 is pi. The equivalent in degrees is 180. And so what we're going to do is say 60 degrees. And so each time through the loop, it does 60 degrees. And see our little error right here? That means we have not declared theta as a variable yet. And since you can see we're working with decimal numbers using radians, we're going to go back over here and create this theta in the float. Declare it here. Theta. And now we come back over here. Let's do a quick save. Come back over here and you can see our error is gone. And so what we're going to do here is create our radius. Now our first one, center point. So what does that mean? Our radius is 0. We already declared that 0 right here. Now we're going to increment that radius. We're going to do the same thing with the plus equals. And then we're going to say, remember the diameter, that's the distance, the size of our circle, and if you put center to center, it's the diameter plus our stroke weight. Now, right here, we have not declared a stroke weight yet. So let's save this, and we're going to go over here and create our little stroke weight. And so what I was explaining earlier is that I kind of like, when I'm working with my stroke weight and a few other things like text size and circle size and diameters and all that stuff, I like working off either the width or the height of the screen. That way if you change any of those, your math will still work, and you don't do what is called hard coding, where you put a hard number in. Like, let's see, stroke weight equals 10. That's a hard coding it. Instead, what we're going to do is we're going to say stroke weight. And since we're doing a division, we're going to turn it into an integer after that math. So stroke weight, we're going to say is width divided by 80. And if you're quick with math, you'll know right away that that answer is 10. Same thing, only if the width changes, because you change your size here, it's always going to work out to be proportionate or proportional. All right, the next thing, let's get back over here. We'll do a quick save and come back over here. And after that, other than our little line that I left blank, what's next? Well, as I said over here, if you don't declare it, it's usually default is 0. But we are going to declare as well our theta equal to 0, because that's our starting point. I'm going to save that. Now, at this point in time, let's see, what else can we do? Can we actually run this? I'm pretty sure that we can, but let's see what happens when we do. We got a blank screen. Basically, because down here in the draw, we did not do anything. So the first thing, like I said, when it's going through, it's kind of like a little flip book or film. When it's going through the draw loop, it's trying to do it 60 times a second, and each time it rewrites the screen over and over again. And if you're doing animations and certain things, you want to blank out the previous one, and do that. We say background. Now, background, we're going to initialize it to be a color. And in processing, color's default is RGB, though it can use hue. And each RGB, red, green, blue, value can be from 0 to 255, the default. But you can change that as well. So for our purposes, using RGB, first one, we'll say red is 255, which turns the red up all the way. We're going to say green is 0, which turns the green down all the way. And then we're going to say blue is, let's say, 200. It's partial, okay? And right there, we can actually get something out of it. You got to spell background, right? We should be able to see what's going on right now. Oh, look what we got. Big, bright, crazy pink screen here. So let's get rid of that. Control save it. Now for our purposes, I'm going to use it black. That's what I've got going on here. I want a black background. And if you're working with grayscale, which would be numbers 0 to 255 default, you only need one. You can have 0, or you can have 255, or any of the numbers in between. We're just going to say 0, and we're going to get us a black screen. All right, control save it. Now, next thing we got to do is call our do circles function. That should be pretty simple. Do, as long as we spell it right, do circles. That's how we call a function. Before we draw our circle, we want to create a color. We want to, right here I'm using a light blue. What we want to do to get that is create a stroke, which would be a color. And it's also going to use red, green, blue. And so what we're going to do is stroke, and we're going to say 255, 0, 255. No. Let's do this instead. 0, 255. So green up all the way, blue up all the way, red down all the way. Okay, we're over in setup now. In processing, when you're using rectangles, circles, or spheres, their default location is the upper left-hand corner. of the circle or the square or whatever. You can change that, and that's what we're going to do right now. We are going to change that using ellipse mode. Ellipse mode, and we're going to say we want it to have its center point as our default location. So center in capitals. Center. Now the other thing we want to do is define our stroke weight. In here, we're going to say, what is our stroke weight? We are going to type in S-T-R-O-K-E, weight, and we're going to say SW, stroke weight. So that gives us the size, it gives us a color, a size of the stroke itself, the lines. And then one last thing we want to do over here, we can do it up here. Might as well do it in here because it's all kind of taking place. Right now it's going to draw circles, but those circles are going to be filled with a default color. So what we're going to do is tell it, we don't want it to fill. We don't want it to have any color inside the center of the circle. We just want the lines. So we're going to say no fill. No fill. Now, we want to define our diameter of our circle. Now, like I said, I like to drive some of these numbers from either the width or the height of the sketch. And so I'm going to use width in this case. And I'm going to say diameter. And we could be declaring this over in our function just as easy. Diameter equals width divided by 6. Now if our screen width changes, the diameter will change along with it. And at this point in time, we pretty much have everything set up enough. Let's see if it will create. Okay, there it is. There's our circle. Actually, right there, there's actually 13 circles, but they're all stacked on each other. We haven't actually created the polar coordinates yet. And so let's do that right now. And so what we're going to do is, like I did before, for another function to calculate polar coordinates, we're going to create another tab, and we're going to call it polar chords. Enter. And then we're going to create the function. Again, we're using void because we want the value to be able to be used globally. And then we're going to say, let's just say polar chords. It's the name of our function. And there it is. And so, as we spoke before, we're going to use, for our polar coordinates and our great big design here, we're going to use this. We're going to use these trigonometric functions. And the first one we're going to create is our x value equals radius times cosine theta. And I'm going to just copy that. And this is where people make mistakes. They forget to change values. This needs to be our y-coordinate, and our y-coordinate is uses sine. There's sine and cosine. And that gets us our values. Now, what we're going to do is, from this function, send it over to this function. And so we want to do polar chords, and each time comes through here, of the 18 times, it's going to come in here and take current values of theta and radius and calculate them over here. Now, what we are going to be doing is creating an index for each point, each center point, so we can keep track of our center points. In order to do that, we're going to create a value, another integer. We're going to call it index, I-N-D-E-X. And what we're going to do over here in polar coordinates is, well, index. Then what we're going to do is initialize that index to 0. And so index equals 0. So when it starts out, it's 0 as well, which if we're using it to help us index our p-vector array locations, starting out as 0 is the first place in the array, first location in the array. And so now what we're going to do is we're going to test this. And we're going to say, when you come into this, our little function here, if index, when it comes into this function, is greater than 12, and so like I was saying before, when you're doing arrays, the first index starts with 0, and if you're doing 13, the last one would be 12. So it comes in here, it's greater than 12, we don't need it to be doing anything more. And so what we're going to do is kick it out. And we're going to use, for brevity, we're just going to say return. We're going to do it on the same line. You have to have that semicolon there, and then we're going to do closing curly braces. This is pretty important to kick it out, or else you end up getting an error further on when you're trying to index your points. And so here what we're going to do now is we've calculated right here through trigonometry, we've calculated the x and y coordinates, and now we have to set them to the locations of in our p-vectors. And so what we're going to do is call our p-vector, and if you remember, it's called C points. If I can remember, it's called C points. And then we're going to say index, which is right now set to 0. And we're going to set that equal to a new p-vector, and we have to set those x, comma, y locations. And at this point in time, if we also had a z location, we could set it there. You can actually set it to 0. It's not going to matter because we're only using the x and y. And so after that, it's made the calculations, check that it's still below the 12 or of the 13 required. It sends it and stores it in the p-vector at the 0 location, and then it increments the index. And that is pretty much that. Let's save that. Okay, then the next thing we want to do before we can run this, when we're starting out to do our circles, what we need to do is each time it comes in here, it needs to set our radius back to 0. Each time this is called over here in our draw loop. It's going to keep calling do circles. Keep calling it. It's already initialized as zeros, and in index, theta, and radius. But once things start going, those numbers change. And you come in here, you're going to have to reinitialize them each time. And what I like to do is add, initialize theta. Now I could say theta equals 0 each time through. Let's see if this gives us anything right here. We're going to hit run, and we get our circles each time through. You can see that it pretty much mimics what we're doing here. Okay, we will continue. Next thing we need to do is our lines. Now let's save this, and we're going to again create another tab for the lines. We're going to call it do lines, and we're going to create another function. We're going to call it do lines. Again, it starts out with void do lines, and again open squiggly braces, closing squiggly braces. And what are we going to do in these lines? Let's first get over here. Let's say what we're doing. What we're going to do is okay, let's just create our loop right here, because basically what we need to do this particular scenario is start with our first circle, which is here. And from this circle, what it's going to do is it is going to, from the center point, draw a line to the center of every single circle. And from here, it just looks like a straight line, but it's actually crossing at the center of every single circle this way and this way and this way. So basically, we're going to start doing that right now. And this is our next nested loop, the while loop. Now we're going to say while. Now we need a variable to keep track of these lines. I think we should call them line index or lindex. So we're going to say lindex, lindex. And while it's less than each circle location 13. And remember, it starts out at 0. And as you can see here, get this. Let's try to put this, initialize this, declare this and initialize it within this function. We won't be using it outside the function. And so we want to say int lindex. We're going to say equals 0. First point. Okay, now let's get to our loop. Now, as I explained over here, this first is going to go through each point. So here's the first point, and then it's going to go through 12 more points, 12 more circles, and draw lines to those points. But it's all going to start from this origin point in the center here. And so we're going to create a for loop to do that, which is the nested part of our nested while loop. And we're going to use the same I as we used in do circles, although they cannot access each other and cannot control each other. These, whatever is created within a function, a loop, if statement, for loop, while loop, all remains within that. Okay, so we're going to say it's equal to 0. We're going to say as long as I is less than, we have 13 points, but we're already using one of them, the origin point. And so that makes 12 points that we want to shoot lines out to. And to do that, we want to say C points this is our array. We want to say C points length, the length of our array. And then we're going to subtract 1 from that because our length is equal to 13. But we are only going out to 12 others. From one circle, you only go out to 12 more. And so we're saying minus 1 here, and then we're going to increment that I by 1. And again, here's our for loop. Now we're going to actually draw the line. You might see the logic, behind this right away. Now when you're defining a line, processing, there is locations that you need to define within the line. And that would be a starting point and an ending point. And each starting point has an XY location and each ending point has an XY location. And so our first starting point is going to be the center of our first circle. We're going to call up C points, and then we're going to, which is now our first circle, and everything's going to derive from that. It's in our array, the first circle, first location equals 0, location 0. And so we're going to call up index, or lindex, which is already set to 0, lindex. And so that's our 0 point. Later on, of course, that changes to the next index. X, that's the X value. And then we want to say the same thing over here. We're going to actually copy paste. And we're going to say Control C to copy and Control V to space and change this to Y. And then our next ending points we've got to create now. Well, what you can do here is you can continue writing and writing, or until you're off the screen, and you can stretch out your screen, so on and so forth, but you can also just drop it down a line. Processing is fine with that. And you might find it useful when you have long, lengthy lines of code to just finish it on the next line. Points. Now we're going to use, our I index. I now is 0. It's also, our starting point is 0. It's pointing to, so if we just put I here, it's going to point right back to the first circle. And what we want to do is actually say I plus 1. And that puts it to the next location, next circle, the next location in an array. So we're going from, starting from the 0 location, and we're drawing lines to the next location, which is the 1 location. And so we create that, and again we're going to do the same thing here, where we're going to copy and space and paste. And this is where people mess up. They forget to change their X to Y or whatever, and boom, you're like, oh no. Okay, and so we're done with this. The lines are created. Now what's happening here is, while this is less than 13 and it starts out as 0, it comes through here, and the first time it comes through, I is equal to 0. And as it comes through this for loop, it starts with the first index on our circle array, our C points, and that is 0. And it gets the XY location, and then it draws a line to the next location, next index in our C points array, which is incremented by 1. And after that, what we need to do, after it gets out of this loop, when it comes through this for loop, increments it. Each time it comes through this loop, I first starts out to 0 and it adds 1 to it, which makes it the 1 location. Then it comes through again. I is now 1, and 1 plus 1 is 2, which is the next location, or the third, 0, 1, 2, the third location in our array. But it's still drawing a line, starting it from the first location. And you can see how this is going to continue. And it's going to do this, the length of our array, which we have -1, which would be 12 times. And after it gets out of there, what we need to do is increment our line index so it knows to go to the next circle to draw the next line. And so we're going to do this. What we've done before is increment it by 1, lindex plus plus. And that, let's control save it, is that we should be able to get our Metatron's cube now. Oh, wait, what did I do wrong? You probably are already saying, you forgot that, da 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 da. Yes, I did. Right over here in draw, after it does the circle, we have to tell it to do lines. Control save. And you can just say Control R to run it. And oh, look. Now, we did not change a couple of things here. Our lines are the same stroke weight, same thickness as the circle. Kind of makes it harder to define. So one of the first things I want to do is change that. When I come into here, let's just change that by changing the stroke weight of it. And we want to say stroke weight. And what we want to do is let's just take stroke weight and divide it by 2. Stroke weight and divide it by 2. Now let's run it. And you can see it's a little bit easier to see, but we can still make it even easier to see. What if we took this and we just said, change the color of the lines when it comes into here and call it, so say stroke. And again, we're going to use our gray value, 0 to 255. We're going to make our lines bright white. And then we hit Control Save and run it again. And we got our white lines. It makes you can see the circles a little bit easier. Now, when you look up, say on Google, a picture of a Metatron's cube, it's actually shown a different way. It is shown 90 degrees from what you're seeing here. And so what I recommend is when you start this process to rotate the whole thing 90 degrees, which is what we're going to do here. And to do that, right here in our theta, we set equals 0. What we're going to do here is change this to 90 degrees. And so we're going to say radians. And then we're going to say 90 degrees. And now we're going to hit that. And it's rotated. And this is the actual way you'll see it. And we are done. But when I started to create this, the idea was to use it in an app that I was creating. I call that app Metatron's Cube Fidget, which you can find on the Google Play Store. Okay, and if you bought a copy, you'd be helping me out. So how I did that, let's go back. First to come over here and save it. Back over here and in our draw loop. One last thing I did, and that was I wanted to save it. Now what this function does, save, is it saves everything in the sketch window at that moment into a graphic file. And so what we're going to do is we're going to call this, let's call it Metatron. And we're going to say .png, save it. Oop, got to have enclosed in double quotes. Now that's going to save our image. Now, if as draw runs, it's just going to keep doing this. It's going to keep saving the image. We only need to do this one time, this loop, this draw loop. And so to kick us out of the loop or to stop the loop, we use a function called no, L-O-O-P, loop. And that, control save, saves our image, which if we go up here in our sketch, you can look in the sketch folder. You can also use control K. Look in the sketch folder and you can see right here that, that the saved image is in fact there. All right. I hope that you found this useful. Now I'm going to try to get this up on GitHub and post a link down below. But just in case I don't, what I'm going to do is I'm going to flip through each of these pages here on our on the tabs on our little sketch so you can copy them down. And so what I recommend here right now is take this and pause your screen, pause the video, write this code. Give you a few seconds, give you time to pause it before I flip to the next one. And next tab, the Do Circles tab. Now, write this code. And again, you do not have to create tabs. You could just write these as they are contiguously below this draw loop. So, pause it here, write that down. And then let's go to the next one. The Do Lines function. Pause it here, write that down. Now we go to our last one, the polar chords function, not very large, but very powerful. Write that down. All right, and I hope that you got something out of this today. If you have any questions, please ask, leave a comment. I hope you all have a great day. I'm Mark, and I love coding.